Okay, hello everybody. Can you guys hear me?
Yeah.
Okay, my face is so dark. I need to turn on the light. Okay, who else is coming? You, Ryan's coming later, and then the other student, I don't think she's coming. She can't be bothered. Hmm. Wait, anyway, uh, so today we have a new student, Adriana. Adriana, this is Hannah. Hannah, this is Adriana. Say hi.
Hi. Hi.
Yeah, so I've been teaching both of you for a long time now. I think Adriana for almost a year. I don't know. I think, no, wait, definitely a year. Yeah, for more than a year now. Because when I started Adriana, I started the tutoring company, and then it was last year, July, June. And for Hannah, I think approximately, yeah, and then after, I think I had taught Hannah after Adriana, but roughly at the same time, like last mid year last year. Yeah, like that. Yeah, so. Yeah, both of you have known me for a long time, and let me just quickly tell you about the like what this course is about. So Adriana, as I said, this is for practice, okay? We're gonna go through some concepts, but we're gonna be mainly focusing on practicing questions, because across all of my students, you guys need more practice, and I can just leave you homework, but I can also organize something like this. We have a lesson, like 2 hour lesson, where most of the time you just try to do questions, and then if you guys have any questions, you can just ask me real time, right? And that's pretty convenient. Why is my face so red? I'm gonna turn the lights off. And then maybe gonna I'm gonna make the room a bit darker, and then my face should look better. Not really. All right. Anyway, it doesn't matter. My face is not the focus of this course. All right, so the first 2 weeks we did quadratics and functions. So Adriana have done quadratics, but you haven't done functions. But I think I mentioned functions a few times to you. If there's any questions about functions today, we might be using some notations. So if there's any questions about functions today, feel free to, or anything in general, both of you feel free to ask me or like interrupt me anytime, okay?
Okay.
One second, let me pull up the lecture slides. Adriana, we also have a lesson tomorrow, right? Tomorrow evening,
Yeah.
5 to 6. Okay. All right, so today we're doing something called rational functions, okay? Functions as a revision, Hannah has done it already. But for you as a revision, function is not as a revision, just like a crash course. Function is an idea. It's not like a math thing. It's more like a concept, more like an idea. Do you remember I told you about functions before, Adriana?
Kind of.
Okay, so it is
Not,
a machine. You can, yeah? What is it?
I said not really.
Okay, so it is a machine, right? We define this to do some job, and then there's an input, there's an output, okay? This is the concept of a function, right? This function, this does something. And we could define it to be whatever we like. For example, we can have a function that does this, that takes the input. So we have this function, takes the input, which is x, and then square it. It gives you x squared, right? And then if we put in, let's say we put in 5, what do you think what do you think we're gonna get out, Adriana?
5 squared.
So what is that number?
25.
Yep, to represent that in the math way, we can just say something like this. We can say f of 5 equals 25. Okay. And of course, there could be other sort of functions. For example, we could have this gx is another function defined as x, 2x plus 1. Okay. So let's say if we put 3 in this function, what do you think we're going to get out?
Oh, 2 times 3 plus y.
What's that?
6 plus y.
1, not y, 1.
Oh, was that 1?
Yeah, 7.
7.
And yeah, as you said, this could be like A, B, C, D, right? It doesn't have to be a number, and function can be really, really abstract. I could design a function and tell me what's the weather of today, and the input is today's date, the output is sunny or rain, stuff like that. Okay. So that's a quick revision on functions. And today we're looking at a specific type of function, which is called rational functions. Okay. So what did we do before? We did linear functions or like linear equations. We have y equal mx plus c. But in function terms, we could have fx equal mx plus c. They are pretty much the same thing. So if you're confused with function and you don't want to study the chapter, you could just treat it like y equals whatever, whatever instead. Okay. Whenever you see fx, think about y. Okay. Because when we're graphing the 2D graph, right, we have x with y. Y represents the output. It's the axis that represents the output. So you can always think of y as fx. Oh, sorry, fx as y. Yeah, we have this linear equation. We also have quadratics, right? Which is ax squared plus bx plus c, right? And we also have exponentials and also rationals. Rational is the function, rational function is the function we're going to focus on today. Okay. So what is rational functions? Do you guys know what is rational numbers? Can anyone tell me what is rational number? None of you? No way. Okay.
Is it like
In that,
fraction?
yeah. Yeah, it's like a fraction. Okay. So Adriana, first of all, listen up, okay? This is important. Like, I mean, like both of you should know this. So humans started doing math by looking at whole numbers or not whole numbers, what we call natural numbers. This is called natural numbers. Hannah, have we done this before?
Yeah.
And then what's the next one? Do you remember?
Um, wait.
Integers.
Oh yeah.
We also call this whole number. So it not only includes 0, but also includes all the negative numbers. Okay, natural numbers, you gotta be careful. Sometimes in some textbook, 0 is included. So in some textbooks, 0 is not. So I like to not include it because where would you see a 0 in nature, right? But I mean, there is some ambiguity, and then with it's like it doesn't really matter. It doesn't really matter. It's just a concept. And then we have a rational number denoted by this Q notation. Okay. Rational number is like A over B, where A, B are integer. Okay, this notation here means A and B are integer. This little notation here means belongs to an element of integer. Okay. Adriana, are there any questions?
No.
So
Not
pretty much fractions. But if I ask you, is 0.1 a rational number? Hannah probably knows, but Adriana, what do you think?
Yeah,
Why, yes.
because it can be made into a fraction.
What is that fraction?
1/10.
Nice. So it is. Okay. It doesn't have to be necessarily represented in the fraction form. And same goes with maybe like 1, right? This is 1/1. Okay. But things that cannot be made into fractions, they belong to the real number, right? Stuff like pi, exponential, square root 2. These cannot be written into a fraction between fraction of integers, okay? And also square root 3, square root 7, stuff like that. And going down this list is layer by layer. What I mean by that is all the rational numbers are real numbers. All the integers are rational numbers. All the natural numbers are integers. So it's like it's kind of like this. You have this circle, natural number, another circle, this is integer. You have another circle that's, and then the last one is real numbers. Does that make sense? I'm pretty sure that makes sense. And you may be thinking, why am I even mentioning this? Because when we say rational, we kind of refer to fractions, right? And when we say rational functions, it's actually two polynomials on top of each other. Rational functions defined like this. I have the definition right here. So gx and hx are two functions. You don't really have to care about what functions means if you don't understand functions. But what it means is that we have two polynomials and then we divide them. The result is what we call a rational function. So this expression is a rational function. All right, Adriana, let me ask you this. Actually, wait, before I ask you this, let me tell you guys what is polynomial. Although in what we're learning today, we're only doing like the first order, but polynomial means x to the power of n, okay? So polynomial, we can have a linear function, okay? We also can have quadratics. This is x squared, but we can also have xn, right? So in general, a polynomial is something like this. So you got y equals like, let's say a x n plus b x like n minus 1 plus dot 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 plus maybe like a constant, okay? Does that make sense to you guys?
Yeah.
Adriana?
Uh-huh.
Yeah, I can do an example. Maybe we can have x4 plus 5x squared plus minus 7x plus 9. This is a polynomial, okay? So if you only look at the second power, this is a quadratics. Ooh, I dropped my pen. But if we increase the power, it becomes a polynomial, okay? And when we have two polynomials dividing each other, we have rational functions. When we have two polynomials divide each other. Okay, so I'm not going to use fx. I'm just going to use y for the sake of being friendly, not using functions to confuse you guys, right? We're going to have maybe like x plus 1, x squared minus 5x plus 9. This is the rational function, okay? Any questions up to now?
No.
No.
All right, the simplest rational function is just oh, you guys will see. Okay, let's do an exercise first. Fill in this table in your maybe own pen and paper, and then we'll compare the answer. Just do question 1. When you're done, type something to me in the chat, or just like, yeah, type something to me in the chat when you're done. Because you want to have pairs of positive integers, right? Okay, Hannah, do you get what the question is asking?
Not really.
Okay, then I'll probably do it. All right, it says fill in more positive integers, pretty much factor this whole thing. You got 1 times 12, 2 times 6, right? Follow the pattern 3 times 4, 4 times 3, and then we have 6 times 2, 12 times 1, right? So that's it. And what we want to do after is we want to plot this thing. And they're all positive, so we can just do something like 1, x is 1, y is 12, right? And then 6 and 2, right? And then 3 and 4, 4 and 3. And then 6, oh, I think I plot this one too low. And then 6 and 2 and 1. Stuff like that, right?
Yeah.
Okay, this is not to scale. This is really bad scale, but you'll see. If I link it up, it's gonna look something like this. Yes?
Mm-hmm.
And what does this say? Explain what you notice about, okay, Adriana. Actually, yeah, Adriana. Look at this question. Explain what you notice about the value of x as y gets bigger.
As y gets bigger, x.
Yeah,
X
what happened to
smaller.
x? Yeah?
Yeah, x gets smaller.
Okay. And same goes for when x gets bigger. So when x gets bigger, we go along that direction. Y gets smaller. But more precisely, it approaches 0. Okay, it gets very close to 0, right?
Mm-hmm.
It's not like smaller to the negative region. It approaches 0. It gets smaller, but it does not cross the x-axis. Okay. So what we just plotted is the line of the graph of y equals 12 over x. Okay. In other words, if we rearrange this, if we move x to the left-hand side, we get x, y equal 12, right?
Mm-hmm.
So the product is 12. Adriana, any questions?
No.
Yeah, make sure you rearrange this correctly, okay? Everyone's stuck here. Like a lot of my students does this wrong. Like they trying to rearrange and then they do the wrong order. Yeah, so they multiply by to 12. So that's where these curves come from, okay? Yeah, it says the end behavior. What do you notice about end behavior? Okay, and also we skipped 3. What 3 tells us to do is we actually want to plot the opposite side as well. So if you think about it, -1 and -12 also give you 12, right?
Mm-hmm.
So then there should be a point here as well, -1, -12. Same goes for every single point. If we make both of them negative, they will still multiply to +12. So this graph actually has 2 lines. So here and here, okay? And there's a symmetry on the diagonal. Does that make sense to you guys?
Yeah.
Mm-hmm.
Okay. So we have just plotted a very basic reciprocal function, rational functions, right? A constant on the top is a, sorry, what's the word? Is a polynomial. It counts as a polynomial, right? It's just a 0-order polynomial. It's x to the power of 0. And on the bottom, we have a first order. We could have like x plus 1 or like x squared plus x, stuff like that, but it just makes it harder. This is the easiest one, okay?
Yeah.
So again, that also reinforces a lesson, which is to plot any graph, you don't really have to understand how the graph behaves. You can kind of just hardcore grind it out by looking at every single possible point. These 1, 2, 3, 4 here. We could even do 5, and then we're gonna get 2.4, right? We could even do 5, and we get 2.4. And 6, we can do 7, but 7 is not gonna get us any integer. And if we do 8, we're gonna get 1.5, right? Yeah, so the takeaway here is that we can grind the graph out. although we don't know what this means yet, we can grind the graph out and know what the graph looks like. Okay?
Yep.
To help you guys visualize this better, as I've always reinforced, use decimals. Okay, look at this. This is the exact graph we just plotted. We could see there's a point 1 and 12, right? And then all the other points are indeed on there. Okay. All right, give me a second to prepare for the next bit. Wait, it's just here. Okay, and we've done this. All right, now there's a concept called reciprocal. Reciprocal, do you guys know what reciprocal means?
The same thing.
Reciprocal? Hannah, do you know?
It's like, wait, is like the opposite?
It's the kind of like the opposite. It's the flip. You flip upside down. In other words, if we have A times B equals 1, right? A and B's are reciprocal of each other. If we rearrange for A, we get A equals 1 over B. So this is kind of like B flipped upside down. Okay? Adriana, do you get it?
Yeah.
So let's say the reciprocal of 3, for example, is 1 over 3. Okay?
Yeah.
The reciprocal of 3 over 5 is 5 over 3. So when we multiply them, they become 1. Okay?
Yeah.
All right. Now, Adriana, do you get it?
Yeah.
Okay, now in the chat, send me in private the answer for B, C, D, F, G, H, one by one. I'll tell you whether it's correct or not.
So all the rest of them?
Yeah, all the rest of them. Because it's not that hard. Yep, Hannah. Yep, just keep doing it. If it's wrong, I'll tell you. If it's correct, just move on. Okay, everyone's looking good. Okay. Looking good. Yep, okay. Hannah, just a little tip. When you're doing D, it's rather than doing -1 over 1 or 1 over -1, you could just say -1. Yeah.
So I don't do anything to it.
You could simplify it. You could say -1. Oh, like technically you're doing something like negative, or you're doing like 1 over -1, but right, but this is just -1. Okay.
So I don't
Is
do
that-
anything.
You did do something to it, but just happens the answer is the same. Do you get what I mean? Adriana, how are you doing with G? Hannah, you can move on to part 2. We have some variables.
I forgot about G.
You could think about which number multiplied by this gives you 1. Okay, nice, that's correct. Before you move on, I'll just explain to you why it's true. So one way to think about it is like what number multiplied by this equals 1, right? And of course, you want a negative number because to get a positive number, you need another negative number, right? And to get 1, you want to have this flipped. So when you actually do it, it becomes something like this. the negative sign first cancels out. You get 8 over 9 times 9 over 8, and that equals 1. And another way of doing it is this, right? Alternatively, we can do this x equals 1 divided by negative 8 over 9. Yes? And because we're dividing, we flip the number upside down, and the negative sign does not matter. The negative sign stays. Or in fact, we can chuck the negative sign to the front and just do 1 divided by 8 over 9, right? So that gives us 1 times 9 over 8, which is which you flip this upside down, because divide change into multiply, you flip it, and then you do your casual multiplication. Does that make sense?
Yeah.
Yeah, make sure you remember this, okay? Very important. All right, in the meantime, let me check Hannah's answer for part 2. Correct. I mean, technically, okay, if you type me 1 over 2x, technically this is 1 divided by 2 times x, and that is not correct. But if you put a bracket here, it's correct, okay? But I get what you mean. So yeah, but when you're submitting stuff online, or like when you're actually trying to be strict, just gotta make sure you mean what you mean, okay? Just just gotta make sure it's clear. 1 over 4y, 4 over 3x, 3 t of d, 3d over 3. And what about last one?
Wait, does this one need brackets as well?
Technically, yes. Like if you don't write bracket, I will get what you mean, but right. If you don't have bracket, I get what you mean, but technically you need bracket. All right, Adriana, do part 2. In the meantime, Hannah, you can practice part 3. Just show those numbers and their reciprocal, then multiply up to 1.
So do I just write the equation?
Oh yeah, you don't have to submit to me. You can just practice it to yourself,
Oh, right.
because you can't really show to me, right? I mean, it's too obvious to me. Okay. Adriana, that's correct. And same problem here. When you write x minus 3 over x plus 2, you need a bracket top and bottom. Otherwise, it looks like you're doing this first. Okay?
Okay.
And for 1.5, you don't do 1.1 over 1.5. You could write this down as part of your working, but in the end, whenever you have a fraction, you don't want decimal in any of the fraction, okay? You either have fraction or, yes, 2 over 3, yeah. And everything else looks fine. All right. Hannah, while you finish this off, like, I'll move on.
I'm
So
done.
yeah, so this part is pretty easy. Say if you got 7 over 11 and then 11 over 7. This is obvious this equals to 1, because when you combine them, 7 times 11 and then 7 times 11 obviously equals to 1, okay? So whenever you have, in general, whenever you have A over B times B over A, this equals to 1, okay? Does that make sense to all of you?
Mhm.
Any question? Adriana?
No, I'm good.
Okay. Take a minute to read this and I'll explain it later. Take like 1 or 2 minutes to read this. Type to me in the chat when you finish reading. Okay. All right, both of you are done. Any questions?
Yeah, I don't get what lim is. Like, I can't really
Ah,
see what's underneath.
okay, lim fx. Okay, whenever you get fx, just replace with whatever fx equals to. This is just a notation because fx, this inside could get really complicated. You could have a function like fx equals to x cubed minus x squared plus 1 over x5 minus x3 minus 5x plus 6. You don't want to write this whole thing. You just want to say this thing goes to whatever when x gets big, right? In fact, this goes to 0 because this term takes over. You just want to say this thing goes to 0, but how do you represent that? You say fx goes to 0. Okay? Oh, lim means this is like a condition. This is saying what happens to fx as x gets very big. Okay? What happened to fx as x gets very big? Oh, fx goes to 0. So lim fx equals 0. Does that make sense?
Yeah.
Another more intuitive way of saying this is literally using plain language. As x approach infinity, this is approach, or we can say goes to. So as x goes to infinity, fx goes to 0. So this is a more casual way of saying this, but it means exact same thing as lim fx equals 0. Does that make sense?
Yeah.
Hannah, do you have any questions? Because you asked me questions about this earlier.
Mm,
Hmm?
mm.
What?
Just can't wait. Can you like go over it?
The limit?
No, like the whole thing.
Oh, the whole thing, yeah, sure. But do you get what this means?
Oh yeah.
Okay. So before I go over it, I'll provide a quick example. Literally the simplest example. So fx, or like y equals 1 over x. Okay, Adriana, just read this as y. Or like y equals 1 over x. We could think about what happens. You know what? Yeah, let's use fx to be consistent with this. So let's say when x is 10, f of x, which is f is 10, is what? Is 1 over 10, 0.1, right? When x is 100, can anyone tell me what is f of x, f of 100?
Mm, 1.
It's 1 over 100, right?
Yeah.
So it's 0.01, or just 1 over 100. Hannah, do you get it?
Mhm.
1 over 100 equals 0.01. So to write it, I'm writing it in decimal so that it's easier to compare the size. What about x equals 10,000? What is f of x? What is f of 10,000?
0.001. Wait. 0.4.
Yeah, the question is how many zeros do you have?
Oh. What?
Yeah, the question is how many zeros do you have?
4?
Does that include the one before the decimal point or not?
No.
And that is unfortunately incorrect. Hannah, how many zeros do we have?
4, including this.
Yes, include. Okay, yeah, that's correct. So divided by 10,000 what are we doing essentially? We have the decimal point here. We have 1, which is 1.0, right? Divided by 10,000 means making it smaller by 10 times, but by 4 times. So divided by 10 4 times. Does that make sense? And that brings the decimal point 1, 2, 3, 4, 4 digits forward to here. So instead we got 0.0001. That's 4 zeros before the decimal point. So 1 over 10,000 is 0.0001. Think about the relative size. Think about what is this actually doing? We're making this 10 times smaller by 4 times. So we're shifting the decimal points by 4 digits. Okay?
Mm.
So 0.00001. Oh, sorry. One too much zero. 001. 3 zeros. All right, so this is a pretty clear example that when x gets large, very, very large, your fx, which is your output of the function, gets very, very close to 0. So this is a classic example of lim. When x goes to infinity, your function, this whole thing is like the notation, right? When x goes to infinity, what happens to this? This goes to 0, right? So lim is part of the left-hand side of the equation, okay? 0 is the right-hand side of the equation, okay? Lim is not like out of the equation. It is part of this equation and it's the left-hand side of the equation, okay?
Mm-hmm.
So that's just a notation. The idea is easy to understand. It's just a lim notation. All right, what does it say? Literally is using the example 1 over x, and it says goes to 0, right? And what does it say after? It says when x goes to negative infinity as well. What does that mean? That means when we have a very small negative number, right? 1 over negative 10,000 is negative 0.0001. It still goes to 0. So sometimes you got to consider the negative case. What else does it say? All right, here, instead of x going to infinity, we have x approaching 0. Then, okay, so first of all, what happens when x is 0? So right now we're looking at what happens when x approaches 0. So first of all, what if x is 0? This is undefined.
Can't it not be 0?
Yeah, we can't have 1 over 0. Yeah, you can't have x equals 0. So undefined, right?
Mm-hmm.
So I shouldn't even write this equal sign because this doesn't really mean anything. That's why we are interested in what happens when it's very close to 0. Because when x is like maybe 0.00, when x is 0.01, right? Which is 1 over 100. F of this is actually 1 divided by that, which is 100. And because of the way the function is defined, we say a function is 1 over x, which is y equal 1 over x. And that is exactly the same as x equal 1 over y, right? So when x approaches 0, y approaches infinity. Okay, you could think about it. If we have f of 1 over a big number, right? 1 over 1 million, this is 1 million. Because you're doing like 1 divided by this, right?
Mm-hmm.
So when x gets infinitely close to 0, but not on the point 0, when it gets super, super close, your output blows up. Okay? That's why the graph looks like this. That's why the graph looks like this. What we did before, remember? So
Yeah.
right now we are interested in this part. When x goes to 0, your y goes to infinity. Okay?
Yeah.
Adriana, does that make sense?
Yeah.
Okay. And it emphasizes we say tend towards, that means approach. Because we say this for a reason, because it never actually get to infinity, right? There's no such point as infinity. And we cannot have 0 inside this function. See, when we put 0 in, like this never goes to a value, right? You can't have 1 over 0. This is simply incorrect. Okay?
Mhm.
So let's see what practice we have next. Okay, and the definition of rational functions, investigation. All right, and then it gets super, super hard. All right, before we move on, I need to introduce to you guys the concept of asymptotes. Okay?
Yep.
Asymptotes. Hannah, have you heard it before?
Yeah.
So asymptote is a line that you approach but you never reach. So for example, you have y equal 1 over x. The graph looks like this. The asymptote is pretty much the x-axis and the y-axis. Okay?
Mhm.
Hannah, tell me what is the equation for the horizontal asymptote? So what is this line's equation?
Y equals 0.
Y equals 0. Adriana, tell me the equation of this vertical asymptote.
X equals 0.
Yeah, correct. You know why?
Because it goes past 0.
It's a vertical line, so x value determines where it's located at. When we say x equal, like say -5, it's this line here. Because at every single point on this line, your x value is -5. Your y value can be whatever. In this case, it's not even included in the equation. That's why we use that to represent the vertical line, okay? And horizontal line is just the opposite. We say y equal whatever, whatever, because at every single of those points, y is that value you're looking for, and x is irrelevant. Okay?
Yep.
Mhm.
Oh, and then of course x equals 0 is the vertical asymptote. CAL. Okay, excuse my bad handwriting, but you should know what it is. All right, now if I make it slightly more complicated. So try to plot this first. See what do you get. Let me think. Let me think what I should make you guys do first. Okay, fill out this table for me. Wait, give me a second. Let me think. Okay, yeah, you guys fill out this table first. Once you figure it out, once you fill it up, type in the chat and plot your graph. Okay? Do you understand what you're doing?
Wait, using the equation.
The second one, yes. Because we want to plot the second one, but you guys really don't really know how to plot it yet.
Wait, I have a question.
Yeah.
Well, I wrote it in the graph. I was just wondering, like, what 3? So, like, it's 3 plus 6 over 3 minus 3.
This is dividing by 0, therefore it's undefined.
Oh, undefined. Yeah, okay.
So you ignore that point. Good question. Good spotting.
So after that, what do we do? Like, plot it on a graph?
Have you done every single point?
Yeah.
Okay, yeah, try to plot it on your paper and see what it looks like.
Okay.
I'll give you a hint. So since 3 is undefined, right? We cannot have x equals 3 as any point, right? It's not gonna have x equals 3 anywhere. So x equals 3 is actually the vertical asymptote, okay? Does that make sense?
Kind of.
You already figured out when x equals 3, you do not have a y value. That means this is your vertical asymptote.
Oh, okay.
We don't know the horizontal asymptote just yet, but once you plot it, you're probably gonna know it. Also, send me the value of your points. I want to make sure if it's correct. Hannah, have you done it?
Yeah, I'm sending it to you right now.
Okay. Hopefully I did it correctly. I've written everything on the board. Let's see. Nice. Both of you have the same answer. That means both of you should be correct. Okay. Yep, try to plot it. Try to plot it in your own table. Your points are correct. Oh, guys, I just have a very interesting thought. You know, I bought a couch. Oh,
Yeah.
I could probably lie on this while talk to you guys. Oh,
I finished drawing it.
okay. Can you spot the horizontal asymptote?
Mm, Was it just 3?
Nope. The horizontal asymptote. What does your graph approach to when x goes to very big? Just look at the positive side. What happens when x goes very big? Oh yeah, it doesn't okay, yeah, 6 is not enough. Okay, let me think about it. Hmm. Yeah, maybe try plot some more points. Try to plot maybe 7, 8, 9, and try to just substitute a very big x value. See what do you get.
Okay.
I actually want you guys to figure this out yourself. And if you figure out the horizontal asymptote, don't shout it out. If you figure it out, type in the chat. I can see. You can ask me any questions along the way. I'll give you guys, I think, 2 minutes, 2 to 3 minutes to do this. The question you should be asking is, what happens when x gets very large? What does the graph look like when x gets very large?
It goes, wait. It gets smaller and then bigger.
Okay, but yes, but that's because on the left-hand side of the vertical asymptote, you're looking at the reflection of the graph. So you should only be looking at one side.
Wait, how are we supposed to find the horizontal asymptote? Because I finished drawing it and I don't know, like,
It looks something like this, right? It looks something like this,
yeah,
right?
yeah, mine does, but like, is that
And,
it?
and remember I said something like, okay, this is a reflection across this axis. There's a reflection. So this is actually a separate part of the graph. What you're trying to find is you're trying to look at the positive side. So what does this go to? The last point you get is 4 and 6, but does it go to 3? No, it goes to some other points. And that's when you want to try some large numbers, see what happens. All right, let's say what if x is 100? What do you get for y? Just shout it out. What do you get for y when x is 100?
1.09.
Yeah.
I have no idea what that is, but you should be having something like 53 over, oh, sorry, 106 over 47, right? Oh, wait,
Nine.
no, 97, my bad. Okay. Yeah,
Mhm.
thanks for correcting me. This number is very close to 1, okay? 1.09, very close to 1. And if you try even larger number, you see that this x start to take dominance, and these two number doesn't matter. It goes closer and closer to 1.
Yeah.
So the horizontal asymptote is 1. Okay?
Mhm.
And the quick way to figure out is looking at the ratio of x. Because we don't have x squared here. If we have x squared, it becomes so much more complicated. But when we just have an integer, or when we just have x, the horizontal asymptote is determined by the ratio of x. Okay?
Yeah.
And by the way, for the left-hand side, for this part of the graph, you don't have to link this. You don't have to link this up, okay? You don't have to link this up. There's no linking. It just goes to infinity and goes to negative infinity here. Does that make sense, both of you?
Yeah.
All right. And technically, if you think about it, if it's a reflection across this line, if it's a reflection, then on the left, this should go to 1 as well, right? It looks a little bit scuffed, but let's make this smooth. It should go to 1 as well, correct?
Mhm. Can you explain how x equals 3 is the vertical asymptote?
X
Like,
equals 3. Oh, simply because when x equals 3, your y is undefined. That
oh,
means there's no value whatsoever when x equals 3. That means, boom, the whole line is blocked out.
oh,
Okay.
okay.
And the horizontal one is slightly more complicated. You got to think about what happens when x and y, x gets very large positively or very large negative. But the easy part about it is we look at x, be like, oh, when x gets very large, these two numbers kind of disappear. So it's just 1 over 1, right?
Yeah.
It's just x over x when x gets very large. This becomes negligible compared to how much x is. Hannah, is there any questions? Hannah, do you have any questions?
No.
Okay. Lastly, do you guys remember how to figure out the x-intercept?
Yeah.
How?
Oh, wait, that's it. Oh, you put y 0.
Yes, Adriana, do you know that?
Yeah.
So figure out the x-intercept for me right now. Okay, Adriana, that is correct. Good job. Anna, how are you doing?
I think I've almost got it.
Okay, take your time, it's okay. Nope, that's unfortunately incorrect. So you should be solving this. Okay. Here we can multiply this across. Okay. There's nothing wrong with multiplying both sides by x minus 3. Except well, actually let me think. Yeah, multiplying this across is totally fine. But we get 0 multiplied by x over 3, so it's just this. So x equals -6. Does that make sense?
What?
So when we multiply both sides by x minus 3, this cancels out on the right. And on the left is 0 multiplied by that. So 0 stays 0. So we only have 0 equals x minus 6 now. Does that make sense?
Yeah.
Cool. And then x equals -6, and that is -6. And you can, if this doesn't convince you, you can always substitute -6 in, see what you get. -6 and -6, you get 0 over -9, which is 0. Okay. So we get a point, -6 and 0, which is the x-intercept. Does that make sense?
Mhm.
All right, cool. Now you know how to find horizontal vertical asymptote. You guys could, okay, I think we'll take a break here. But if you guys are not that tired, we can move on. But we'll take a 5-minute break. We'll come back at 7. Oh, not for you guys is 7. Wait, no, for Sydney is 17. 17. Oh, we'll come back 17:08. Okay, for Auckland is 19:08. Okay. But if you guys don't want to take a break, you guys can start doing these questions. And for Hannah, you can do the domain and range. But for Adriana, you haven't studied domain and range, so just find the asymptotes. Okay.
Okay.
Ignore the first one. But if you want a break, we can take a break for now, and then we'll come back at 5 minutes. Because I need a break as well. But during the break, we can chat if you guys want, or if there's any questions. All right, can you guys hear me?
Yeah.
Hello, Ryan.
Yo,
Do you know what we're doing?
nah,
Do you know asymptotes?
nah,
Yeah, you're screwed.
voila.
Oh my god. Okay, I'll spend like 3 minutes telling you what it is, but if you don't get it, you are screwed.
Yeah.
Okay. Before, in the meantime, yeah, at the same time, not in the meantime, at the same time, I will show you guys the graph we just did. I think -3, I believe, and then y plus 6. See, the intercepts here.
Mm-hmm.
X equals 3, and then have we done anything like this before, Ryan?
We did x plus 1 and x minus 1
Oh
last
yeah,
time.
it's pretty much the same thing.
Okay.
So here, you can see this graph approaches 1 when it gets very large, okay?
Yeah.
And the negative side as well. So, but it never really gets to 1 because no matter how large x is, the 6 and -3, there's always like a tiny difference. It doesn't really approach 1. But
Wait.
when x gets very large, it goes very close to 1. Yeah?
So it's like the same as the previous one.
Yeah, it's the same as the previous one.
Yeah.
All
Okay.
right. The horizontal asymptote is, you think about it as x go very large, what happens, right?
Yeah.
The vertical asymptote, however, is simply the denominator. The denominator cannot be that number, then it cannot be that number.
Oh.
So the denominator says I can't be 0, so x minus 3 can't be 0. That means x can't be 3. So 3 is the vertical asymptote.
Oh. Okay. And so
Okay.
I would always be y for the asymptote and vertical it's always 3, right? I mean
1 and 3, yes.
Okay, got it.
X and y, you mean? Yes, vertical is always x, horizontal is always y.
Yeah.
And another way you could think about it, also this is to everyone, so Adriana, Hannah, please listen up as well. Another way to think about the vertical asymptote is that what happens when we go very, very close to 3? That means the denominator goes very, very close to 0, while the numerator is approximately 3 plus 6, which is 9, right?
Mm-hmm.
So 9 dividing by a tiny number gives you a big number. Does that make sense?
Oh, yeah. Okay.
What about Hannah and Adriana?
Wait, say it again.
So another way to think about the vertical asymptote is that what happens when x goes very, very close to 3? When x gets very, very close to 3, x minus 3 gets very, very tiny, right? And the numerator is approximately 9. So 3 plus 6 is 9. So we have 9 dividing by a tiny number. And the result is very large.
Wait, Michael, why is that x equals 3 and isn't that the y-axis though? Like, what the goose?
You mean it's vertical? Is that what you mean?
Oh, wait, never mind. Yeah, I get it now.
It's vertical, so it's determined by an x value.
Yeah, my bad.
Across this line, see, this is 3 and 29, 3 and 22, 3 and 15, 3 and 88, 3 and 42. Y is irrelevant here. Only the 3 is locked in. So across this entire vertical line, your x value is 3. That's why this line is x equals 3.
Mm-hmm.
Okay?
Yeah.
Cool.
Mm-hmm.
So, all right, that's that. Maybe I should take a screenshot. All right, now I want you guys to take some time and work out the horizontal versus vertical asymptote of these numbers, of these equations. Okay? And notice how it's saying rational functions, but it is using y on the left-hand side. And that pretty much means sometimes when we have fx, you can just treat it like a y. Okay? So now try to work this out. And once you got those, work out the domain and the range. Adriana, you don't have to. Adriana, just do this.
Okay.
All right. Any questions, ask me. And if you get the answer, you can send it to me in the chat. First one's easy. We've done the first one.
Wait, which one are we solving? Like the y?
Everything. Vertical asymptote and horizontal asymptote.
No, but which question?
All
Which-
of them.
Oh,
Do it one by one. Hannah. Wait, okay, that's before. Okay, never mind.
yo, Michael, can you explain like asymptotes again? Like how you're meant to solve for them?
It is okay. Hannah, do you want to explain that to Ryan? And if you're wondering why I'm asking you, is because the process of teaching someone else actually helps you reinforce your memory. So that's why I'm asking you.
Wait, Michael, is the top the vertical or the bottom the vertical?
What are you asking?
Like, how are you meant to
The
find the
vertical is the vertical. You mean how you find it? Okay, in this case, whatever makes it, whatever x value makes it undefined. Anyway, Hannah, the
Yeah.
question is, how do you find the horizontal and vertical asymptote? By the way, if you don't know, you can just say you don't know.
I don't know.
How do you find the horizontal?
Oh, you make one of them 0. I can't remember which one.
Yep, the denominator, because the denominator results in an x value potentially being undefined. Adriana, that is correct. You want to say x equals 0, okay?
Okay.
Brian, you sent it to everyone, but yes, that is
Oh,
correct.
shit, my bad.
No, all good. Horizontal is y equals 0 as well, because when x gets very big, your y approached 0. So the graph, we did look at this earlier, is the very basic graph, is this. Do you guys remember?
Yeah.
Hannah?
Mhm.
And don't worry about the domain and range for now. I haven't taught you guys that. Just move on to the next question.
Wait, so Michael, the goal is just to make the equation undefined, right?
For vertical asymptote, yes.
But for horizontal, do you just replace it with a 0? The x
No, for horizontal, what happens when x gets super, super large? All right, Adriana, first of all, explain to me how did you find the vertical asymptote for the second question?
I put like 1/0 plus 2, and that gave nothing.
So,
So it's undefined.
so you're saying x equals 0 makes the graph undefined.
Well, no. What? I thought x equals 0 was
Yeah.
the asymptote.
Yeah. You said 1 over 0 plus 2 is undefined, right?
Yeah.
So you're saying x equals 0 makes the graph undefined, right?
Yeah.
And that is how you find out horizontal asymptote. Yes.
Horizontal. Oh, okay.
Sorry, vertical.
Oh, okay.
Yeah. So it pretty much means okay, rather than like kind of saying 1 over 0, just look at the numerator, be like, okay, for what value of x does the numerator not allow us to have? Right? You can't have x equals 0. That means the vertical asymptote is just x equals 0. It means your graph will never get to this line. Okay? All right, the question is the horizontal asymptote. How do you guys figure out the horizontal one? Hannah, unfortunately, that's not correct. I'll tell you how to figure it out. What happens when x gets very large? Just try out the value, see what happens.
And y?
Yep.
Does it get smaller? Wait, from
Yep, it approaches something, and we want that something. So what number does it approach?
who?
That's nice. Okay. Yeah, that's your horizontal asymptote then.
Okay.
Oh, damn. Okay.
Okay.
Wait,
Then the third one, yeah.
how are you supposed to find that out if you don't know what x is?
Oh, you look at the graph. You never know what you don't never have a specific point. For this one, you don't know what x is. You just know that it goes very large, and your y approaches 0.
So do you substitute x with 0? Is that why?
For horizontal, no, you
Yeah.
substitute with a large number and see what happens.
A large number.
Okay, let's just take 2 as an example. Hannah, are you confused as well?
Yeah.
Okay, let's say this is your graph, right? Are we all clear that the vertical asymptote is x equals 0?
Yeah.
So we're trying to find a horizontal asymptote. That means what happens with y when x gets very large. So just try substitute some numbers on scale of 10, right? So tell me, what is y when x equal 1? Adriana, in the meantime, you can move on to question 3, or you can just listen. Yeah, Adriana, probably just listen because you got the third one wrong.
Oh, I did.
Wait, is there a third one or not? Oh no, that's correct. That's correct. Okay, my bad.
Oh, okay.
Okay, but maybe listen up as well. This might help. Okay, anyone tell me what is y when x is 1? We're talking about the second question.
3.
Okay. What about 10? Anyone just shout it out. Any of you?
2.1,
Okay. What about 100?
2.01,
Okay. What about 1,000?
2.001.
Okay. Only Hannah's answering. Adriana and Ryan, do you guys get it?
Yeah. Oh,
Okay.
no,
Yeah.
I thought we were doing the third one for like this.
So like if we draw the graph, we get something like this. X equal 1, y is 3. X is 10, like it goes very close to 2. So it pretty much just approach 2, okay?
Okay.
So y equal 2 is your horizontal asymptote.
Mm-hmm.
It approaches 2 but never gets to 2. This is obvious enough, right?
Mhm.
Hannah, do you get it?
Mhm.
Okay, cool. Now I'll do question 3. Before you guys do question 3, I'll give you guys a hint. What we are doing right now is simply a vertical shift of the first graph. This and this is simply a vertical shift.
Wait, Michael, can you check the answer I gave?
That was correct.
Oh,
And when you refer to a line, use x equal, y equal to instead, okay?
okay.
All right, cool. All right, and for the remaining of this lesson, we'll just do a lot of practices. And Ryan, do you have any questions for your math exam? If there are, we'll leave like 5 minutes, we can do those.
Not really.
Okay, that's fine. Hannah, that is correct. All right, Adriana.
Huh? Oh, are we doing 3?
Yeah.
Oh, I'm doing that.
Did you guys use the fact that is the vertical shift?
The what?
I told you like the +2 and the -3 is actually just a vertical shift, shifting up and shifting down. Did you guys use that fact?
No.
Oh,
No.
interesting. Okay. Adriana, if I tell you the third graph, it is just the first graph shifting down by 3 units. Can you tell me the horizontal asymptote and the vertical asymptote?
Wait, can you explain that again?
This is our first graph, right?
Mm-hmm.
If we shift it down by 3 units, what do you think the horizontal and vertical asymptote is going to be?
Like
Yeah.
1? Well, I don't know what you're asking.
This whole thing shifts down. Your vertical stays the same. Your horizontal shifts down by 3 units. It becomes y equals -3. And the entire graph just goes down by 3 units. Does that make sense?
Yeah.
So you're moving everything down. And it is shifting down by 3 units because you have y equals 1 over x minus 3. The -3 goes directly to the right-hand side. It means you're moving the whole thing down.
Mm-hmm.
So for example, before, yeah,
I thought we were doing, wait, question 3.
oh, okay. Sorry, my bad. It's this one. It's like the last space we haven't filled.
Oh, okay.
All right, everybody listen up. So why is it shifting down? We've been through this for functions as well, but I would like to reinforce. Think about it. Well, for whatever x value we have, for example, x equals 1, 1 over 1 equals 1. But now x equals 1, this is 1 over 1 minus 3. So this -3 acts on top of what we have before. It literally shifts every single point down by 3 units. Does that make sense?
Yeah.
Mm-hmm.
Ryan? Okay. So domain and range is actually pretty much the same because for reciprocal function, they extend to infinity. So domain and range is just that you can't x can't equal 0, x can't equal 0, x can't equal 0, y can't equal 0, y can't equal to 2, y can't equal to 3. Okay? Adriana, you don't have to worry about this. Ryan and Hannah, do you guys get this?
Yeah.
Mm-hmm.
Okay. And look at this. Does it say anything about it? Oh, when you transform graph, oh, what am I saying? When you transform the graph to this, describe the transformation. It literally goes down. This shifts up, this shifts down. What happened to the horizontal asymptote? Oh, it shifts with the graph, right? And the vertical asymptote, because it's perfectly vertical, shifting up and down does not change the line. Do you guys get what I mean? If we have a perfectly vertical line, shifting it up does not do anything.
Mm.
That's what I mean. So vertical asymptote is not affected. We don't have to worry about this. What asymptote rational? Oh, can't be bothered. Okay. Now it's just some basic stuff. Let's do see right now we haven't touched anything on oh wait, we don't even have those kind of stuff. Yeah, remember in the beginning I did something like this, x plus 6 and x minus 3. We don't even have this kind of stuff. We don't have anything like this on the top.
Oh.
Instead, they just add something after that. But I guess that's fine because in this case, when we have a rational function like this, let's say 1 over x minus, let's say k and plus h, when we subtract something to x and plus something to the entire function, k and h is the translation, is the horizontal and vertical shift. Does that make sense to you guys?
Wait, so Michael, for C, would that... Oh, wait, never mind.
Does that make sense? So k and h effectively transforms the graph from y equals 1 over x to a graph like this. And h and k are the vertical and horizontal shift. H we just talked about is shifting up, or if it's negative, shifting down. And k is doing something directly to x. And we talked about this before. If it's subtracting k, we are shifting it right by k units. Does that make sense?
Mm-hmm.
Ryan?
Mhm.
Adriana, does that make sense?
Yeah.
I actually don't expect this to make sense to you because you didn't come to the last 2 lessons. So if you say no, it sounds more realistic. So does it make
Okay.
sense?
No.
Okay, that's good. It's okay. I will do something. All right, as I said, it's gonna make sense just in a second, and that mod cannot be reached because I put in the wrong. All right, as I said, y equals 1 over x minus h plus k. As we can see, we can add h and k as sliders. Okay, so we do that. And we can see, okay, remember what I said k is? K is like the number that's added at the end is the vertical shift, right? So notice when I shift k up and down, oh, sorry, that's h. When I shift k up and down, it goes up and down, right? To make it obvious, I should probably do this. Oh, sorry. Okay, I just added a horizontal and vertical asymptote to the red graph, okay? Now if we shift, oh, that's h again. If we shift k, see it literally goes up, right? Any questions?
No.
So are you guys convinced by this animation?
Mm-hmm.
All right, for the horizontal one as well. If it's 0, let's make k 0. If they're both 0, it's just the original graph. They are the same, they're overlapping. But now if we try to shift it right, boom, We increase h, we subtract by, in this case, 6. It's shifting right by 6 units. Okay? Adriana, does that make sense?
Kind of. Yeah.
Kind of. Okay, that was the answer I was expecting as well. I mean, like, okay, if you think about it, what this really is doing. So when I say h equals 6, k equals 0, the graph we are looking at would just be, okay, let's shift it up or shift it down a little as well. Maybe shift down by 4.5 units, sure. So right now, what this means, what it's saying is that the graph, the red graph we are looking at, the theory says it's a shift right and down from the blue graph we have. And what is that graph? That graph is this 1 over x minus 6 plus 4.5, okay? So that's what this notation altogether means. Does that make sense, Adrian? Oh, sorry, minus 4.5, my bad. Does that make sense?
Yeah.
So we're saying this graph is a translation from the graph we had before. And yeah, that's it. So in this case, we can just identify, wait. We can identify the asymptotes using the old method, right? By looking at the numerator, right? X minus 6, it can't equal 0. So the horizontal asymptote is x equals 6. Okay? This makes the denominator 0, and the whole thing is undefined. What about the vertical asymptote? When x gets super large, what happens? When x approach infinity, your y approach what? When x approach infinity, this term goes to 0. 1 over infinity is 1 over a huge number is 0. So your y is just a negative 4.5. So this is the classical way, without considering the shifts. This is the classical way of figuring out the asymptotes, which also works. Does that make sense?
Yeah.
Ryan?
Yeah.
Adriana?
Yeah.
Seriously?
Kind of.
Okay. So, okay, Adriana, try to explain to me, given any like these type of function, how would you figure out the horizontal and vertical asymptote? Give me like a crash course in 30 seconds. I'll give you a minute.
Oh. For the vertical asymptote, you try to see like, wait, no, the horizontal asymptote, you kind of try to see which one the number y gets closer to in the end. Is that right? Like,
That's vertical.
oh,
Oh wait, am I choking? Oh my God, guys, I choked. Did you guys not realize that? Well, okay. Actually, because there's the vertical lines, the vertical asymptote. X equals 6, not 0. X equals 6. This is the vertical asymptote. This is the horizontal. Sorry if that confused you guys. Does that make sense? The horizontal one is what happens when x gets very large. That's the horizontal one. I accidentally wrote down the wrong thing. Does that make sense, guys?
I think.
Wait, so the horizontal one is the one that the vertical one is the one that you replace as 0, like x as 0.
Yep.
And then the horizontal one is the one that gets smaller.
When s gets very large. Sorry, I should have wrote infinity. I mean, I did say when x gets very large, but I wrote x equals 0. Sorry. Yeah?
Yeah.
Okay, so Adriana, okay, I'll just say this again, and Adriana, you try to like explain it to me. The same thing, okay? So the vertical asymptote, right? You were doing this pretty well. So you're looking at the denominator. So when the denominator equals 0, when the denominator is 0, sorry guys, just the doorbell. I need to see what is up. Weird. All right. So when the denominator is 0, the function is undefined, right? So in this case, x minus 6, it cannot be 0. So the vertical asymptote is x equals 6. Okay? And for the horizontal asymptote, is what happens when x gets very large. When x gets very large, your y approaches some value. And in this case, when x gets very large, this fraction is gone because your denominator is too big and this goes to 0. So all that's left with is negative 4.5. So in this case, as it gets large, your y value approaches negative 4.5. Questions? Okay, Adriana, try explain to me the concepts. Actually, you know what? Instead of you explaining now, we can do a few more practices. I think that will help. All right, find the horizontal and vertical asymptote of, let's do B. Actually, yeah, let's do B. So if once you get it, you can send it to me in the chat.
Wait, Michael, am I correct?
Oh, sorry, I didn't see it. All right. Oh, all of you get. Wait, no, I'm missing Adriana. Hannah, unfortunately, that's not correct. You don't substitute x equals 0 in, okay? The x that makes the function undefined is not substituting x equals 0. Substituting x equals 0 gives you the vertical, or gives you the y-intercept. Okay, I'm getting 3 different answers. Ryan, I think that is... Okay, Ryan's incorrect. Adriana is correct.
Oh shit, my bad.
Adriana correct again. Nice. Ryan correct. And now vertical is correct.
Are we meant to move on to the next question?
Yeah, sure. Once you get this one, do D. And then do F, do G. Actually, you know what? Do H. Actually, do G and H. Yeah. Hannah, how are you doing?
Wait, do we do D or no?
Yes.
I'm really confused.
Okay. So remember what we said about vertical asymptote, which is the hard vertical line here. By the way, this is not related. I'm just using the graph as an example. Okay. The
Mhm.
vertical asymptote means on that line, x is not defined, right? And the
Mm.
only way, yes?
No, keep going.
Yeah, and the only way for like the graph, sorry, not x, for the graph to be undefined on that line is the numerator is 0. So the numerator essentially cannot be 0. So we cannot have any value on that line. Sorry, denominator. Right? Because we can't divide by 0. This is just fundamentally wrong. So x minus 5, this cannot be 0. So your vertical asymptote is x cannot be 5, which is pretty much like x is 5, right? The line itself is x equal 5, okay? It's this line, okay?
Yeah.
And the horizontal asymptote is what happens when x gets very large. And in this case, what do you think happens when x gets super, super large?
I don't know.
Remember what we just did?
It
You
gets
were,
really.
you were shouting out answers.
Michael, I finished answering.
Yep. When x gets large, I'm just going to make this very, very large. What happens with y? Tell me what happened when x equal 1.
It gets smaller as it goes larger.
Yeah. Yep. Just tell me what is x when y equals 1. Just as a fraction, it's fine.
One over -4.
Okay. What about 10?
1 over 5.
Wait, give me 1 second. Yeah, okay, yeah, keep going.
1 over 95.
Keep going.
1 over.
No, 95. This one is kind of odd because we have the vertical asymptote here. On the left-hand side should be this. So you're looking at what happens here on the right-hand side. You're looking at what happens here, right? It obviously approaches 0, right?
Mm-hmm.
It gets tiny and tiny, tiny. It gets really, really close to 0, okay? So that's why the vertical asymptote here should be, the horizontal asymptote here should be y equals 0, okay? It's the value that they get
When you're
very
working
close.
that out, do you have to do it in the table? Is there no like other way to do it?
Oh, you could just look at a graph, intuitively think, okay, when x gets very large, this becomes like very big. 1 divided by a very big number goes to 0. So you don't have to work out in the table. You could just like, when you get very fluent with these kind of stuff, for example, this one and this one as well, when x gets very large, numerator is 5. 5 divided by like 1 million is close to 0, right? Just picture a very large number, substitute it into x, see what happens. Okay.
Mm-hmm.
All right, let me check the other answers. Ryan, that is correct for 2. Adriana, did you do second one?
Wait, I kind of like don't understand how to do that.
B or D?
D.
Use the same reasoning.
Wait, Michael, which one of mine was wrong?
It's correct.
Oh,
But why did you say 5 and -5? What is your final answer? Decide on one.
oh no, that was from the previous one. I was changing it.
So
So
for D, is it -5 or 5?
-5.
Cool. Okay.
-5 and 0.
Okay. For G is I'm looking. Okay, Ryan, I think you have everything correct. Hannah, that's correct. Adriana, yeah, that's correct. Are you guys just copying Ryan's answer?
Wait, did I send it to everyone again?
No, you shouted out. You said -5.
Oh,
No, I use my brain.
Okay, cool.
Wait, I still don't know how to do the
Horizontal.
yeah. Like how much
Just look at the graph. Be like, what happens when x gets very large? X is 1. This is 5/6. Okay. Doesn't really matter. X is 10. this is 5 over 15. X is 100, this is 5 over 100 over 5. X is 1 million, this is 5 over 1 million and 5. It goes very, very close to 0. That's a tiny number. Make sense?
So won't all of these just be 0?
You can try on G. Try G is different because this part goes to 0, but you have a +2.
Oh, right.
Remember? 3 is the horizontal shift, +2 is the vertical shift. It shifts your horizontal asymptote up. But that's like another way to think about it. All right, so everyone's on G now, right? Ryan's finished everything. Hannah, why -2? Yes, yes. Yes, okay, Hannah, that's correct. Ryan, do you want to explain to everyone? Okay, Adriana, yeah? Adriana, correct? Yeah, Ryan, do you want to explain to everyone? Okay, Adriana, that's correct as well. Ryan, do you want to explain to everyone what did you do for question G?
I just used the same reasoning for everything else, to be honest.
Okay, so just say it out.
It goes to infinity, and also I like just did +3 because I do like the inverse for everything on the denominator, and the plus I just did like the normal one.
I don't get what you mean. Explain in more detail, as if you're teaching someone who doesn't know this.
Well, normally I just like look at the denominator and then I like reverse it or inverse it. Then for the positive, like the plus and stuff, well, like the stuff after the fraction, I just put that in because that's how I've been doing it the whole time.
Yeah, I mean, I get what you're saying, but if you're someone new, if it's a new student, they're gonna have no idea what you did. You don't inverse it. Okay, the proper way should be, okay, Hannah, do you want to explain it? Try your best.
It's lucky because I still don't understand the reasoning behind it.
Okay, Hannah, try explain it.
Well, I just do wait, I look at the denominator and I see a -3, so I just make it into a +3.
What if I say the denominator is 1 over 2x plus 5?
X equals 2.5.
Yeah, so what did you do there? You
Oh,
didn't
I
do
made it
-5?
I made it so it doesn't equal, so it equals 0.
Yes, exactly. That's what you should be saying. You should be saying when x is 2.5, the denominator is 0. And you can't divide by 0 because
Oh
that
wait, it's
results in
wait, is it -2.5?
it's -2.5. You're right, good spotting. So when the x is -2.5, the denominator is 0, and you can't divide it by 0. So that's why this is the vertical asymptote. That should be the whole thing. Okay?
Okay.
In other words, the graph cannot attain any value on this vertical line. That's why it's dot, 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 dot. Okay? And about the +2 part, yeah, it's fine, because in other words, you could just say when x gets very, very large, what does y become, right? This term disappears because that goes to almost 0. And you are left with the +2. So that should be the reasoning. Okay, and Adriana, that is correct. So you've been doing pretty much the same thing. Okay,
Mark, for the 1 over 2x plus, is that a j? What's the reasoning behind that again? You just like,
that's a 5.
oh, 5. Shit. Oh, you just, okay.
You want to find the x value that makes the denominator 0, and that is the value we cannot have, which
Okay.
is the vertical asymptote.
Yeah.
Okay, because you were saying you're looking at the -3, you make it positive. I was like, okay, let's make it this different. This is not -5, right?
No.
All right, we have 5 more minutes left. Let's do something slightly. Okay, let's do this. Let's just start something slightly different. Actually, you know what? Instead of doing that, we should do this. The last one. So for 3, it says each of them is a transformation of 1 over x, right? It's 1 over x shifting left, right, up, or down. Match them, okay? Once you match them with the 5 graphs, once you match them, send it to me. Just say A, whatever, B, whatever, C, whatever, okay? Okay, I'm getting 2 different answers for A.
Oh wait, I don't think that's right.
You're so not confident.
Wait, is it right?
I said I'm getting 2 different answers. It means one of you are right.
I don't, 2 of these graphs look the same, so I don't. Wait, all of these graphs look the same.
No, oh crap, they are actually the same. Wait,
Yeah, I can't
Two-
find anything.
Oh,
Two
how
and-
am I?
wait, 2 and 3 are so similar. But okay, yeah, now there's a slight difference. There's a slight difference. There's a slight difference between 2 and 3.
What the actual goof?
Okay, Adriana, that's not correct. Adriana, tell me what is A? Hannah, that is correct. I'll tell you that's correct.
Really? Oh my
Yeah.
God.
What?
Remember, I said you do something directly to X. That is the rightward shift. Yes?
Yeah.
Hannah, do you remember that?
Mhm.
So X minus 2 here is the rightward shift. Was that your reasoning?
Who are you asking?
You.
Oh,
Or did you look at the asymptote straight away?
I just looked at the asymptote.
Yeah, the asymptote also that works. The asymptote that makes it, but all of them has asymptote equal 2. I'm telling you guys, look at this. The denominator,
I
all
just
of
looked
them
at
is
one
X
and
minus,
two. Okay.
all of them
Oh.
asymptote X equals 2. Okay?
Yo, what was the answer?
It's 2.
Wait, what?
A is 2.
Oh shit.
Okay, because all of them has asymptote 2, so you can't really do much from there. But you know A has 0 as the horizontal asymptote because minus 2, this is, remember before the Desmos, this is a rightward shift by 2 units, right?
Wait, is my second one correct?
Yes? Good try. Second one's actually interesting. Okay, anyway, we're back to, okay, oh, Adriana, I'm pretty sure that's correct. Yes. Ryan, unfortunately incorrect.
Wallah, bro.
I mean, I'm helping you guys by giving you like yes or no's, but like try get it right. Hannah, correct? Nice.
Wait, Michael, for 3, why does it have? Oh wait, never mind. I'm
For
honest.
3 or C?
3.
Yes, this is very similar to 2, and I'll tell you why later.
What the goof?
But slightly bigger, right?
Yeah.
Adriana, that is correct, Adriana. Hannah, that is correct. Hannah, did you get all of them? Or are you
Yeah.
missing one? Oh, nice. Okay. Ryan, that is not correct. Ryan, B is -1, right? What does -1 do? It's essentially having a negative sign in front of what we have in A, right?
Okay.
So A is this. What does the negative sign do to a graph?
Moves it to the right.
No. You have a -1, but that is not a rightward shift. Having -1 here is that negative in front of it is -1 times that. It's not a -1. okay?
Okay.
So negative flips the graph around the x-axis. So before, we probably have x and y when x equals to like, okay, I shouldn't say this. I'm saying for whatever we have before for a, right? The negative sign makes it negative. So it should look like this. It's flipped. Does that make sense?
Oh, so it's 5.
It's like this. It's like we have y equals x squared. What about y equals negative x squared?
Okay.
It is this, and it is this, right?
Yeah. Okay. Okay. Okay.
The only graph that's flipped is 5, so B is 5.
Yeah.
All right, let me look at the new answers. Hannah got everything. Ryan is choking. Adriana, you gave me 3 different answers. B5 and E3 is E3. Okay, yes, that's correct. Adriana, did you get them all?
What?
Have you got them all?
Yeah.
Yeah, you got them all. Okay, nice. In the meantime, since you know the answer, just try to reason yourself out. Ryan, that is correct. Yeah, that's correct. Okay, everyone's got everything. All right, that's pretty much it. It was a tough lesson. It was harder than I expected. But to summarize the main things we learned today, okay? I mean, let me just quickly write this down. Okay, I forgot to talk about this. This is slightly fatter than 2. It means the 3 on top is kind of stretching it up, okay? That's why they're pretty much exactly the same, but this is C. And the shift up is the +2, which is, oh, sorry, this is E. The shift up, the +2 is C, and the shift down, -2 is D, okay? All right, let's just summarize everything today. So the main 2 things we did was horizontal asymptote and vertical asymptote, okay? This is the vertical asymptote. And the horizontal asymptote. So vertical asymptote, we look at the denominator. And solve denominator equals 0. And the solution is the vertical asymptote, okay? Right?
Hmm.
For example, we could have something like 1 over x minus 3. This gives us x minus 3 equals 0. X equals 3. This is the vertical asymptote, okay? For the horizontal asymptote, you ask yourself, what happens when x goes to infinity, when x gets very large, okay? That's it. That's just the main thing we did today, okay?
Mhm.
And no stress if you don't get this. I mean, this is like what you're gonna do mid-year 12. Hannah, you're gonna do this maybe in like a few months. Ryan, you're gonna do this next year, and same for Adriana, you're gonna do this next year, okay? So no stress if you don't get it now, but I'm just preparing you for what you're gonna be doing next year. So yeah, if there's any questions, feel free to ask me anytime. And in the meantime, do we have any questions now?
No.
Okay. All right, so in that case, I'll see you guys next lesson. Next lesson will be about exponentials, so it'll be easier. It'll be something you guys are familiar with.
Bye-bye.
All right, see you.
Thank you.
Thank you. Bye.